Yeah, welcome everybody to my talk about how to measure IT security by using MITRE ATT&CK. Some words, additional words about me, myself. I have a master's degree from the Ruhr-Universität Bochum in IT security. And I'm pretty into, like Jen already told you, into the offensive part. And use my knowledge to currently building up SOCs and blue teams so they get, from the attack perspective, a better view on the defense in general. Yeah. So why should we measure security? So let's talk about the motivation. Imagine you have a bigger IT environment, let's say in a company. And in this IT environment, you have distributed responsibilities. Like you have some guys that are managing the clients, you have some guys that are managing the servers, web applications, and so on and so forth. And those guys are also doing some changes in the environment. And as a security team, I'm not directly into control of this. So I can only see the results of those changes or by talking to the people and get the information. So it would be great for me as a security practitioner to get these changes directly on a regular basis. So I can state, for instance, assumptions about my environment and say, hey, I need, for instance, this very important firewall rule, and say that my environment must be like this. Or for the security operations center, you have a use case, for instance, and you want to check if this use case is still working all the time because you're getting the right logs and there's nothing missing. So would be great to have something to measure this and to verify this so that we can build security on confidence from our security perspective. So for this, let's talk about MITRE ATT&CK first. So what is MITRE ATT&CK? In general, MITRE ATT&CK is a framework with generic attacks in it. Those generic attacks are categorized in different tactics, the so-called tactics here. This is the upper line here, where I can say I have something like initial access, so how do I get into the company, execution, so I get my code executed, and so on and so forth. And then we have the generalized attacks that were described on a very generic way here. And so what can you do with it? Because it looks at the first glance like a boring table. Okay, it is sometimes. But you can do with MITRE attack modeling. So MITRE is also doing this for you. So it is modeling some attacker groups or attackers in general. And let's see how it works. So for instance, I use for the initial access for a company, I use the phishing techniques. And then I get execution via the native API, for instance. Then for persistence purposes, because I get a foot into the door and I want to keep it there, I create an account for me so I can come back because the system is reachable over the internet. Then I can probably set up do a privilege escalation to get system rights in the system by doing DLL injection, and then I can get my credentials during the credential dumping phase. So like this, you can in general model your infrastructure. But oftentimes in compliance-driven companies, I see that MITRE is a bit misused because this is not a checklist. Because each and every technique here is only a generalized attack description. You have multiple layers under it. For instance, you can do the native API execution by using PowerShell or by using C# or something else that you can imagine. So you have many multiple ways in general to do your actual attack. So because we can also use MITRE by adopting it on our company, for instance. I made an abstract picture of that, so we can play through some scenarios for us and say, hey, come, I take the tactics, and derive techniques from that to model a scenario for me. Let's say an attacker is doing some reconnaissance previously, then he is setting up an email and say, hey, I will do the initial access by doing a phishing attempt, adding an attachment to have execution probabilities so that I, for instance, execute the command line and dropping my code on the machine. Then on the machine itself, it calls back via, for instance, HTTPS, thanks to Let's Encrypt, fully encrypted to our command and control server, and then gets the next attack steps. Okay, now we're on the machine. We can say, "Hey, come on, we want to stay there and doing some persistence." For instance, like I said before, we just use a DLL injection because we found a program or a service that is searching for a specific DLL, and we noticed that. Okay, so now we're system on a Windows client, for instance, and the next step is for us. For privilege escalation purposes, after that, the next step is moving laterally. So when we're a system, we can simply dump ELSAs if we do the right steps before and jump to the next box. And here we found, for instance, some text files for the next machine and doing some collection and exfiltrate the information to a different server in the internet. And so you can adopt all the tactics with derived techniques and play with MITRE ATT&CK in general to get a feeling and an overview of your attack landscape and play something through. So, okay, we saw now MITRE ATT&CK, but how do we measure? So, in the past, we did our security testing, for instance, like something like red teaming, where we hired an external red team and said, "Hey, come on, guys, hack my company and give me a report about that and tell me how I can improve that." And then, this is good. This is very important, but it's most of the time it's doing only annually. So you have a snapshot of one time in the year about your current security state, and only one or two different ways into your company. So the next candidate might be penetration testing, which is a more focused approach where you can say, I want to test this machine or that machine or the entire network, this web application, and so on. It's also good, but imagine you have 5 pen testers and 800 machines. That doesn't scale. So then also a candidate is vulnerability scanning, which is also great because it's a broader approach. But vulnerability scanning is more focused on the CVEs and in general. So you can just patch the system and you're fine. You can measure it with that, which is good. So it might be a part in the general security program here. But you can't just test with it some architecture problems, for instance. Then there are different offensive or defensive tools that are mostly working like black boxes where you automate your test behavior. But what I would say to use, or what might be interesting to use, is that we, as a security practitioners, model our expectations about the environment and say, hey, guys, we want, for instance, this firewall rule must be there, or the web application must be authenticated like this, and or this CM rule must be triggered under these conditions. So it's more like the mindset of the software development lifecycle, where when you use the test-driven approach and say, "Hey, I write a test for it and check if my condition that I want to have is there." So how can we measure that with MITRE? So we simply use MITRE and put it into, for instance, atomic red team. This is one way to do this. So let's dive into it. So what is atomic red team? Atomic red team is actually a MITRE use case that you can model with a simple YAML file and run it like an attack. It's actually an attack in general. So You have different sections here in a atomic red team case. The first one is the input arguments. Imagine this like variables for a function. Then you have to check the prerequisites. Then you run the attack itself, and you're cleaning up the system to become the previous state again, to be clean. So, okay. Let's show this on a small example. Let's say we have some source files here because we want to run a stager, which is written in C# and have an output file somewhere in temp. Then we have a prerequisite that we need a special compiler and also the access to this compiler. And then the next step is to compile the code and run the attack. And after that, we remove all the files that we generated like this. Okay. This is an atomic test, which is great, but for measuring, it's not enough because we need criteria. Without criteria, we can't measure anything, and we can also validate anything. So we need at least success or failure criteria to say this is a successful test or it's a failed test. So when the attack goes through, the test is successful itself, but it's a failure for us because the attack is working. So let's look at the example here again. We have at least 3 different criteria here. So we need to get the compiler must be existing, and we need access to this compiler because I can block it by, for instance, app blocker, and then an attacker is not able to use it potentially. And then I want the stager to do what the stager is doing, connect to the command and control server, and load the next stage. And then we have a successful attack in general. So this is also nice. Let's zoom out a bit more because, yeah, atomic tests are good and great to have a test scenario, but it's very, very limited on one point. So if you want to run a chain of attacks with a bigger scenario like we showed before that you can definitely model, you need chains. And each and every chain has the success criteria and a validation step. So when the chain fails somewhere, you know why. Another thing is that some MITRE attacks are not really possible to get modeled like this. So imagine you're modeling create a count like an attack. It might be interesting on different systems, but it's pretty limited. So you can model it like for a ZM use case to test it, that I create an account doing something in between and delete the account again. Otherwise, I would just mimic administrative behavior, which is not intentional then. So how can we use this methodology? In general, you must choose your must conditions. So you have to be focused on that. You gather them and then you prioritize them. So the most important you will implement. Because we have everyone has only 8 hours a day, so we have to model it like this and focus. And to start with a bunch of those cases, for instance. Then we create the cases, so write our expectations to our environment and say, hey, it must be like this. Then we run the test, we validate the test, and then we improve our environment. And then we can go on and on and on and create even more of those tests. And then we can measure in the end our environment like this. So how to express this in numbers, for instance? We can use it with MITRE, with the metrics, and say we have a technique here. We have modeled, in general, 5 tests like this. We are mitigating 4 of them and alerting only 2 of them. The goal should be to mitigate and alert every 5 of them, but sometimes it's simply not possible because you have way too much false positives. And another very important aspect is that you focus on your environments. So we have, for instance, the Windows environment, then we have the clients for it, and we want to model those tests there and see if they are improving or changing, and how the current security posture is over there. So then we also can measure this over time, making a regular iteration about this. So the time intervals is up to you. So you can run it daily, you can weekly, monthly, but not yearly. And you have different categories here. The red ones are the attack is successful, so I have to do something. Then the attack is mitigated. I have countermeasures for this in place, like hardening stuff here. Then we have monitoring. So we at least getting the logs and can read the logs after the successful attack. But this is a prerequisite for the get alerted thing. So that we have a ZM alert, for instance, and say, hey, now we are also getting a notification when this happens, even when it's mitigated. So we can also go a bit deeper into this, that we can write down some cases pretty briefly. So let's take, for instance, the LSAS dumping via run.dll. Here the attack is successful. We categorize it in MITRE and we defined countermeasures. We have a risk scoring within it. So how important is it? How fast do I need to act here? And we have a scope. For me, a system here is the whole system, like the environment of the company, and local is more the local machine. It's only affected there. And you have some guy that is responsible to mitigate or to do the stuff behind the successful test case. Okay, so we're coming finally to the end of my talk. So what are the advantages of this strategy? So we have a reproducible methodology to measure our security posture in general. So also we can recognize changes there. So if one of the divisions is maybe not intentional at all and changes some security settings, then we want to recognize this and we want to get notified here. And we also, in general, getting the monitoring gaps, because with this approach we can also test our CM use cases on a regular basis, and we have not only isolated attacks, and we can model more sophisticated scenarios for us to test those. And the most important thing is then your security posture gets verifiable. So thanks for your attention. Now I'm open for questions.
Okay.
Hello.
Hello.
Thank you for a nice talk. One question about, in case of you using the atomic red team framework to measure detection in the area of EDR products, where set you the line or split the line in case of, I would say, in case of you dump credentials from the LSAS process, you can execute your atomic, I would say, artifact. Mm-hmm. And this is more or less the idle case. But compared to when I use the same technique with from a framework like Cobalt Strike or Brute Rachel, where can I set the line that I say, okay, yeah, it's okay, we see this, but compared when I do the same technique based on in-memory encryption, other things, I do not longer see this technique. Where can I say, okay, it makes sense to do it in this way, or to say we see it at this point, but not longer after we use Cobalt Strike or other tools.
In general, you have to prioritize first, that you can say these are the attacks that are More probably for my environment, you can use the tactics from a Cobalt Strike and you implement it first when you say this might be an attack that that takes place in my environment, and then you have to model this. When you have a deeper memory stuff that you have to model, okay, you need to a bit more work to work on this case.
But then you use the framework to prove the visibility, to prove the detection. So when I execute an artifact from atomic red team, I will maybe the app products will see this, but especially in case of ELSAs, there are now many ways to dump it in a different way. Yeah. So, for example, you open or you search for an open handle which is already open in case of service host process, and then I do not longer see it. But wow, what can I say then? Is it enough, or should I say, okay, I know there will always be a way to bypass or do it, but from my own experience, it's always hard to find the line. So okay, until this we see everything, but then it makes no longer sense, or
it depends. The one thing is that you have, what you already stated, is that you have different perspective and angles that you must implement, that you want to see. And then you can trigger those, and then you can detect this. But when you also detect this, then you have some kind of ZM use case, let's say, and you build it. And then with Atomic Red Team, for instance, you can trigger this use case. And that's more than, in this scenario, the better idea, actually.
Okay.
Yeah. Because you don't have all the time in the world. So.
Okay. Thank you.
Hi, question regarding the test case input files, basically. So you define it and then you just run it. Has anyone already provided a large library of predefined test cases that you can just use?
Yeah, Atomic Red Team is a repository on GitHub where you exactly have this. Many predefined use cases that you can use and build up.
How many use cases do you have?
Roughly. Question. Several hundreds, I would say.
Question 2, the example you showed was about Windows, right? Some attack on Windows. So this is executing on one host machine. How well does this work on a network-centric perspective, something that spans multiple machines?
There you just set up a test machine for that, and then you penetrate your environment, like the network. I would set it up like this.
Okay, thanks.
Yeah, you're welcome.
Any other questions for Marcos? All right, then please give Marcos a hand. Thank you very much.